This is the fourth and final video on the demand curve and the second on elasticity of demand. And this time we're going to look at elasticity along the demand curve. And at the beginning of the most recent video, I asked about whether a firm should raise or lower its price if it wants to generate more revenue. And that's going to depend on the elasticity of demand. So let's take a look at two examples here. One is an ice cream shop struggling with a cash flow problem, needs to raise revenue quickly. Should you raise or lower the price for the cones that you sell? Similarly, if you look at a pharmaceutical company struggling with a cash flow problem and must raise revenue fast, should it raise or lower the price of drugs? And for both of these, it depends where along its demand curve it is. But we tend to think of pharmaceuticals as very inelastic in demand, and ice cream is elastic in demand. There are many substitutes for ice cream. There are few substitutes for prescription drugs that we may need. So let's take a look at this. We can draw it up. Here is the demand curve for the ice cream cone. It's selling at a P1 with Q1 cones sold each day. Here is the market for the pharmaceutical company with price of P1 and Q1 pills sold each day. And now we can look at a price increase going from P1 to P2 for the ice cream cones causes a decrease in the quantity of cones demanded from Q1 to Q2. And similarly, an increased price in pharmaceuticals raises the price from P1 to P2. And notice that although there is a decrease in quantity demanded, it's far less because consumers are far less responsive to a change in price with pharmaceuticals than they are with ice cream cones. Looking at the change in revenue, the green area for both shows the revenue generated from a higher price. Going from P1 to P2 creates more revenue for the company, but then it loses this revenue from the decreased quantity being sold. But with the ice cream cones, we can see that the red swamps the green area, therefore raising the price in the ice cream shop caused revenue to decrease, whereas in the pharmaceutical company example, a higher price, because the green swamps the red, caused revenue to increase. So given the example, and again, it's not just the slope of the demand curve that dictates what elasticity is, but given that I start at the same price quantity combination, that slope is meaningful. And what this says is the more inelastic the demand curve, raising the price in this case would increase revenue for the pharmaceutical company, but it would decrease for the ice cream company because that's elastic in demand at that point. And we can look at this with looking at elasticity and revenue given our simple equation of quantity is equal to 10 minus P. And here's our typical demand curve. And then looking at the total revenue based on quantity, here we're looking at 10 and 10. And we know that at a price of 10, quantity is going to be 0. And at a price of 0, quantity is going to be 10. But in both of those cases, revenue will be 0. If the price is 0, you're not going to generate any revenue. If the quantity is 0, you won't generate revenue. And so revenue rises and falls and comes to a maximum right here at 5 and 5, given this example. And that's our maximum revenue at that point. Revenue is increasing from 0 to 5, and then revenue is decreasing from 5 to 10. And we'll see how elasticity corresponds to that. Maximum revenue is at 25. When you're on the inelastic portion of your demand curve, raising price, which is the same as decreasing quantity, causes revenue to increase. When you're on the elastic portion of your demand curve, raising price, which is the same as decreasing quantity, causes your total revenue to decrease. So if I'm on the elastic portion of the demand curve and I want to increase revenue, I want to lower my price and sell more units. If I'm on the inelastic portion of my demand curve, I want to raise my price and sell fewer units. And that's because on the elastic portion of the demand curve, the percentage change in the quantity demanded decreasing exceeds the percentage increase from the price increase. It's the opposite for the inelastic portion of the demand curve. Now keep in mind, revenue maximization is not the optimal goal for a company. It's going to be profit maximization. At unit elasticity, this is where we have revenue is maximized, right here at 25. And again, when we see marginal revenue, it's going to be 0, and that happens when elasticity is unit elastic. So we can take a look at this with our equation again at a price of 10, quantity is 0, and it's going to be perfectly infinitely elastic at that point. Any increase in price causes quantity to decrease infinitely. total revenue is 0. Lower the price to 9, 1 unit sold. Elasticity is -9 at this point. Total revenue is 9. Lower it to 8, 2 units are sold. Total revenue is 16. Elasticity is -4. Marginal revenue is 7. And we can see on down the line how lowering our price causes quantity to increase and how that affects total revenue, and then we see the marginal revenue corresponding to this. So what this tells me, when I'm on the elastic portion of the demand curve, lowering my price causes revenue to increase. Notice that marginal revenue is positive but decreasing. It is still positive. On the opposite side, when I'm on the inelastic portion of my demand curve, when I raise my price, revenue is increasing. And notice that marginal revenue is negative at that point, but as I move upward, it's negative at a decreasing rate. So I want to continue raising my price to increase revenue if I'm on the inelastic portion of the demand curve, and I want to do the opposite on the elastic portion of the demand curve. And right here, the unit elasticity, we see that total revenue is maximized. We look at 2, we talked about point elasticity of demand. And we talked we noted that the elasticity of demand is the percentage change in quantity demanded divided by the percentage change in price. We then broke that up to be the new quantity minus the old quantity divided by the old quantity divided by the new price minus the old price divided by the old price. I'm going to substitute that Q2 minus Q1 with delta Q, which simply says the change in quantity divided by quantity, and substitute P2 minus P1 with delta P, which is simply the change in price. And we can see change in quantity divided by the change in price over price. And I can bring that denominator up, and we have the change in quantity with respect to a change in price times price over quantity is the formula for my point elasticity of demand. And if we look at an equation, we can see that dq dp simply says how much does quantity change as price increases by 1 unit. So when it goes up by $1, and we can see that's going to be -1, and that's simply the coefficient in front of p. And then we can take price over quantity, and that tells us where we are, the elasticity of demand at that given point. Given a more complex equation, if we run a regression, we would have the coefficient in front of the price of x to determine elasticity at this point. So let's take an example. You estimate by the equation 10 minus p. You are currently selling 4 units at $6. If you raise your price to $8, you expect to sell 2 units. What is the point elasticity of demand at this price quantity combination? Go ahead and pause the video and try to calculate that. Okay, given that you were selling 4 units, that's the old quantity. The new quantity is 2, so 2 minus 4 divided by 4. The new price is 8, the old price is 6, so 8 minus 6 is equal to 6. That's a 50% decrease in quantity demanded and a 33% increase in price. That's the elasticity demand is going to be minus 1.5. Using the equation I just used, the slope of the demand curve is -1. Price over quantity, 6 divided by 4 is minus 1.5, and they're the same thing. So you're getting the exact same answer. One is calculating based on the figures on 2 points, and the other is simply using the slope of the demand curve in order to calculate where at that given point, what elasticity is at that given point. So what is arc elasticity of demand? We talked a bit about this. The arc elasticity of demand measures the elasticity of demand between 2 points. It tells me what, it's a midpoint of elasticity between 2 larger points. Say we're looking at 10 minus p. We want to determine the arc price elasticity of demand between a price of 8 and a price of 5. What this would tell us is it would give us the elasticity right at 6.5. So if we look at the arc price elasticity of demand using that same equation, 2 minus 4 divided by 2 plus 4, 8 minus 6 divided by 8 plus 6 gives us minus 2.33. So the point elasticity of demand at $6 and 4 units is minus 1.5. The arc price elasticity between $6 and $8 is minus 2.33. And we can see that here. Here was the minus 1.5 when the price was 6 and quantity was 4, and that gave us the minus 1.5 for our elasticity. But looking at it between a price of 6 and a price of 8 and a quantity of 4 and 2, this gave us the arc price elasticity, which was the midpoint between 4 and 2 or 6 and 8. And so the arc price elasticity of demand measures in between 2 points. The point elasticity of demand is right at that point. In this case here would be the quantity of 4 and the price is 6. Now let's get back to our ice cream example. Suppose ice cream cones were $3 and the ice cream store was selling 100 cones per day. Total revenue is $300. Lowering the price to $2.75, quantity increases to $125. Total revenue now increased to $343.75. By lowering the price, the revenue would have decreased for this company. And we can calculate the elasticity of demand at this point, and we can see that it's -3, which is elastic in demand. Looking at the arc price elasticity, the exact same thing is -2.56, and it's elastic in demand. Switching to the pharmaceutical example, let's say a price of 30 and a quantity of 7 pills per week, $210 per week. Raise the price to 40 and 6 pills per week, you end up with $240 per week. The elasticity demand is -0.42, which is inelastic in demand, whereas using the arc price elasticity, it's -0.539. That concludes the videos on demand.